So in this video we're going to convert these recurring decimals into fractions. Now recurring decimals I've written here with a vinculum on the top. You may see these with an arc, for example 0.37. You may see this with an arc, or you may even see this with dots. So you might even see it like that. So there's different ways you can see it, but today I'm going to use this straight line above it, which is called a vinculum. Okay, so solving this into a fraction. So 0.4 recurring. So what I want to do is, first of all, is to try and get a whole number in front of this decimal point. So the way I can do that is to multiply this by 10. So if I do that, I will do 10 times 0.4 recurring. That will then give me 4.4 recurring. Okay, so now how can I solve this? Well, I'll start off by letting x equal 0.4 recurring. So x equals 0.4 recurring. So now here, with this calculation here, I can see that 10x equals 4.4 recurring. Okay, now if x is 0.4 recurring and 10x is 4.4 recurring, if I do 10x minus x, so for example, if I do 4.4 recurring minus 0.4 recurring, that will just equal 4. So then I'm left with 9x equals 4. So now I can just solve for my x. So x equals 4 over 9. That's dividing by 9 both sides. Therefore my x, which is 0.4 recurring, is 4 over 9. So that's how I can represent that as a fraction. Now what about this one with two recurring decimals? So this one here, 0.37 recurring, would be like 0.37, 37, 37, 37, and so on and so on. So for this one, I would let my x just equal this. So x equals 0.37 recurring. So now with two recurring numbers in the decimals, so that's my tenths and hundredths, I can now multiply this by 100. So 100x, that will then just shift these two across. So 37.37 recurring. That will give me what my 100x is. So for example, if I move this here, that will be the equivalent of just putting my decimal point there. So you can see what's going on here. And now I want to get a whole number in here. So what if I do, if I subtract this first x, I will get rid of this 37 recurring. So a 100x minus x would just be leaving me with 37. So now I've got 99x equals 37. So divide both sides by 99. So now x equals 37 over 99. Now 37 is a prime number, so that is going to be my final answer. Okay, now what about this one? 3 digits this time. So same principle occurs. Whatever number of digits occur, we need to try and transfer across that many times. So just to write this one out, I've got 0.293, 293, 293. Now my goal is to try and get this 293 this side of my decimal. So this time if I multiply it by 1,000, so 1000x, that would equal 293.293 recurring. So that would be the equivalent of taking this decimal point and just putting it here. Okay, now I want to try and get rid of this. So therefore this is my x, so I just set my x equal to this. If I just subtract this here, so this one here I've got, that was my original. My x is 0.293, 293, 293. If I subtract from this, I've then got 1000x minus x equals 293. So now simplify this off. 999x equals 293. So now divide by 999. So x equals 293 over 999. Can we simplify this any more? 293 is a prime number, so we'll leave it at that. So that's going to be my final answer. Okay.